GE's Dash 8 series of locomotives would represent the first model in which GE's sales would rocket past EMD's. EMD for the longest time having dominated the sales of locomotives in the North American market thanks to its simple two-cycle combustion prime movers, which due to their extremely compatible nature with other EMD prime movers, would often allow for parts to be swapped between the particular families and or series of prime movers in which EMD produced, even if they were more modern ones. This, coupled with the sheer number of these locomotives available on the second-hand market or even as scrap locomotives for parts and parts in general, kept keeping these locomotives in service very easy and very inexpensive. Not to mention the fact that many mechanics were trained to work with the two-cycle combustion prime movers, and again their simplicity of design. All of this was despite the fact that the GM prime movers at the time, which were all two-cycle combustion, such as the 567 and the 645, tended to guzzle gas quite noticeably, especially compared with GE's products at the time. But again, railroads were more than happy to take the hit on fuel consumption if it meant they got a very reliable product, which was still the case, at least for the current time. While GE had successfully outwitted Alco in the late 60s, taking them out as a competitor altogether, and having successfully taken second place in terms of locomotive production in the United States from Alco years before this, and now was essentially the only other locomotive producer in the United States for factory new locomotives other than GM, it was still a very distant second place. There are a few main factors holding GE back at that time from getting a better foothold in the North American diesel locomotive/road switcher market. To start with, GE's products weren't exactly known as the greatest thing since sliced bread, to put it mildly. Early models like the U25B, its first road switcher introduced in the domestic road switcher market back in 1959, suffered intensely from problems with their prime movers, electronics, and most infamously, the fact that they tended to rust out or dissolve in the rain, as some mechanics have put it, much like an Alka-Seltzer dropped into a cup of water. Then there was the increased complexity of the GE products' prime movers. At that time, the prime mover GE utilized in its U-boats was known as the FDL-16. This would later be refined into what was known as the 7 FDL prime mover, which would replace the FDL-16 and prove a huge step forward in getting GE to dominate GM. Another factor that pushed GE's locomotives back in the market was a question of quality control in general, with in addition to the rusting issues, parts literally falling off their earlier production locomotives. And there was the fact that these locomotives tended to be very lackadaisical, especially compared to Alco and GM products in terms of responding to throttle inputs by the engineer. The GE products at the time featured an 18-notch throttle as opposed to a GM/EMD product's 8-notch throttle. This is designed to give the engineer more control over how much power output they got. The only trouble was engineers wanted more power more rapidly, and the prime movers of these early GE products, even into the Dash 7 series, which would replace the U-boats, tended to be very slow and again lackadaisical. The dislike of these locomotives by engineers was so extreme that it wasn't common for locomotive engineers to refuse to operate these locomotives or even threaten to quit over having been forced to run these locomotives on a consistent basis. Now, it wasn't that GE wasn't trying here. The company had learned a lot from its former partner Alco in terms of customer service and satisfaction, and in sharp contrast to Alco, it could afford to dig into its pockets and basically make any necessary changes to its products. The problem is figuring out what changes would actually work to solve the issues customers were complaining about. Still, the situation was so extreme, despite having a noticeable horsepower advantage over the products being produced by EMD at the time, not to mention a noticeable fuel efficiency advantage at that point, it still lagged very noticeably behind anything EMD was selling. A good and quite extreme example of this is that total production of all of GE's U-boat models put together only equaled that of one of GM's lowest production models, its GP30. Worse still for GE or General Electric, while the company continued to struggle with its U-boat and Dash 7 series of locomotives, GM would continue to dominate the market with its production locomotives even if they failed to make horsepower outputs, and by a noticeable 2-to-1 margin 9 out of 10 times. Making things even more miserable for GE at the time, the General was slowly but surely closing the horsepower output gaps thanks to its 645 series of diesel prime movers, which would debut in its 40 series of locomotives. While these prime movers were still comparatively not as efficient as the four-cycle combustion GE power plants, fuel prices still hadn't quite hit home enough to drive the customers away from GM's products. And with enhancements to the efficiency of the current production GM prime movers, although not major, and of course the extremely massive reliability difference between the GM and GE products, again GM dominating here, as their locomotives were considered almost indestructible, and at the same time, even if they did suffer failures, were extremely inexpensive and easy to repair, AMD continued to easily outperform GE in terms of total locomotive sales. This, needless to say, was about to change. With the late 1970s United States oil crisis, fuel prices once again jumped, and products like EMD's SD45 with its massive V20 two-cycle combustion prime mover, which was a complete and total gas guzzler even compared to its 16-cylinder models, began to make these models look like the equivalent of wearing Bermuda shorts, for example, to a very important business meeting. Not a good idea, to put it mildly. This caused the railroads in the United States at the time to take a good and much closer look at the products being produced by GE, which with their four-cycle combustion prime movers could produce more horsepower, but most notably with less fuel consumption than the EMD products at the time. And while GE's then current series of locomotives during this period in time, known as the Dash 7 series, wasn't really where it needed to be to take on EMD head-on at the time, a seed had been planted, and these engines slowly but surely started to get more and more respect from railroaders and railroad companies alike. GE, with its deep pockets and customer service-oriented mentality, the latter being, much like its former competitor Alco had once had, emphasis on the customer service aspect, not the deep pockets, mind you, also continued to listen closely to its customers' feedback. One particular railroad in which the company was successful in getting a leg up with was the Monongahela Railroad. The company had approached EMD about a custom locomotive to help its coal-hauling trains, which required quick, snappy acceleration but specific modifications in terms of horsepower output, but most notably to allow the locomotives to negotiate tight clearances. Note the clearance modifications were very minimal. GM, again with its, and I quote, lovely customer service mentality that essentially it made the best products, promptly told the company to basically modify its railroad to meet its standards, and then to come back when they were finally ready to seriously purchase a locomotive. Oh, and not to let the door hit them on the way out. And if this does sound like deja vu, yes, this is essentially what was going on with the Alco RS1 way back in the 1940s. Feel free to check my video on that locomotive, as you'll find there are a lot of similarities as to what happened here, essentially one company not learning from its history. The Monongahela Railroad then approached General Electric about a new type of locomotive that would handle these specifications, similar to what it had asked GM for. In sharp contrast, and essentially doing things the way its former partner turned competitor Alco had done in the past, when at the time very extreme modifications were requested of its models, such as the modification of Alco's then S-series of switchers, which would turn out to be the Alco RS1, GE happily sat down with representatives of the Monongahela Railroad and not only openly offered to make massive modifications to existing models it had in its production line, the company even came up with suggestions as to how to best meet the customer's requirements. The end result of this was a special modified variant of what was then GE's only factory rebuild locomotive model, the Super 7, which in turn were rebuilds of GE's earlier U-boat models, designed to accelerate more rapidly and carefully designed to deal with tight clearances. Needless to say, these locomotives, once finished and once up to the customer's standards, were a huge hit, thanks to updated and tweaked electronics that were easy to maintain, much more so than previous GE products and even GM products at the time, which were again modular and very easy to swap out, one of the first times this sort of technology had been employed on locomotives, to a drive/propulsion system that caused these locomotives to take off like rocket ships, especially compared with the U-boats, and easily rivaled that of the current production GM products, which are again nowhere near as efficient as the four-cycle combustion 7FDL's 16 prime movers employed on these locomotives. These locomotives did such an excellent job of satisfying what the Monongahela Railroad had requested of them that even some of the railroad's former engineers that had worked with Penn Central's former property, the Pittsburgh and Lake Erie Railroad, which ran a lot of the more infamous earlier GE U-boat models, and thus had developed a huge hatred for anything GE, were quickly converted once they had taken the controls of these locomotives. With future indications that fuel prices would continue to rise in the United States, plus the fact that emission standards were getting tightened, GE began to realize it had the perfect recipe for a new locomotive type that would dominate the entire market and finally allow it to pull ahead of GM, especially if it had combined all the lessons it had learned working with customers thus far with this new particular locomotive model. And so sometime in the mid to late 70s, GE began brainstorming this new series of locomotives that would finally put it on top. GE began to design a whole new type of locomotive that would be largely based upon the Dash 7 series but noticeably upgraded, with microprocessors controlling the locomotive. This would allow for further improvements in efficiency as well as reliability, not to mention diagnostics, making it easy to repair the locomotive compared to previous GE and even GM products. As well as further advancements in such things as wheel slip control, something GE had initially inaugurated in its original U-boat series of locomotives and it enhanced in its Dash 7 line, but would take another notch further with its Dash 8 line of locomotives. Advanced wheel slip detection, mind you, would become a standard requirement of all future locomotives from all companies. This would essentially be one of the first, if not the first, applications of this sort of technology in railroad locomotives. The engineer would also utilize a computer screen to monitor key aspects of the locomotive's operation. Essentially, this would replace a lot of the gauges depending upon the particular variation of this new locomotive type, allowing for more precise readouts and more readouts in general than would ever be available to the traditional gauge-equipped locomotive, as again, there's only so much room in a locomotive cab to place gauges. The new locomotive design would also have a modular construction philosophy, allowing parts such as the prime mover, cab, and other such internal components to easily be swapped out between different CRI of locomotives, allowing GE to more easily hit special niches in the market and at the same time maintain profitability. This very diverse line of locomotives with many options available, not to mention noticeable enhancements and improvements over its former predecessors, as well as its competitors' line of products, EMD specifically, would debut in 1983. Another interesting note, some of GE's other models from the Dash 7 series were still in production, such as the B36-7, while Dash 8 production was beginning to slowly but surely ramp up. Initially, GM didn't seem much concerned over its competitors' new products. After all, it had just introduced its new GP and SD50 series of locomotives, which, thanks to its new 645F type prime mover, utilizing just 16 cylinders, featured a maximum horsepower output of 3,500 horsepower. This, however, would be this locomotive's Achilles heel. The development cycle of this particular prime mover was rushed to get it into production and thus keep a leg up over GE and or stop sales from hemorrhaging off of GM. As again, the only thing EMD could offer at the time with this sort of horsepower was its V20 variant of its 645 prime mover, which again was simply too much of a gas guzzler to compete in the current market, especially considering the fuel efficiency of the products GE was pushing out at the time with its 4-cycle combustion prime movers. The main issue being is that EMD had set up the 645F to rev much higher than its predecessor 645E without really taking into consideration as to what this would do to the prime mover itself, especially in terms of longevity. The end result, this prime mover would suffer crankshaft, not to mention complete and total engine block and other such noticeable powertrain failures. And if this sounds familiar, yeah, that's pretty much what happened with Alco's 244 when the company rushed it into production with at least something resembling a test program, although again very much rushed. In this case, EMD, apparently thinking, well, it was the king and no one was going to topple it, decided to just push this thing out and cross its fingers. And it would have been bad enough if this was the end of this particular series of locomotives problems, but as it turns out the electronics were also prone to chronic and major failures. More headaches. Again, making GM sound much more like GE at this point. GE, on the other hand, had been working on its electronics and refining them and testing them and fixing the issues they had had with these electronics and getting them to function the way they were supposed to, which meant that while they had promised big and failed to deliver originally, they were now promising big and delivering. One could easily make the statement in hindsight that EMD should have known better by this point. But again, that was not the company's mentality at the time. After all, they were GM. Where was anyone else going to go for their locomotives? GE? Well, yeah, that wasn't a smart move at all. That's pretty much exactly what happened. By the time these failures were happening, the GE-8 series had started debuting, and many railroads found that this locomotive was much more practical in terms of what they wanted, especially in terms of its enhancements in terms of fuel efficiency, in terms of diagnostics, in terms of sheer features and quality control, emissions. Not to mention horsepower output, with some examples reaching in excess of 4,000 horsepower. This again gave them an advantage in terms of being able to pull a longer train with fewer locomotives. Not to mention the fact that this much horsepower rated for a single locomotive was unheard of at the time these locomotives were produced during the mid to late 80s and early 90s. In short, at the worst possible time for itself, and at the best possible time for GE, GM had laid an egg, and GE essentially picked it up and threw it right back in the company's face. In short, after a somewhat sluggish start, the Dash 8 series of locomotives proved very successful for GE. Exact numbers are hard to come by, as there are several different variants of this particular model. Speaking of the different variants or variations of these particular models, here are some of the more notable ones. A quick note again on the designations that GE gave its locomotives. The letter designation B or C, which can come either before the model number or after, depending upon how it is listed and which naming system is being utilized, determines how many axles the locomotive has. B for 4 and C for 6. The number preceding or following the letter, again depending upon which naming system is being utilized, determines how much horsepower the locomotive has. And finally, and of course, the Dash series indicates what series the locomotive is from. In this case, all of these locomotives will be Dash 8s as they are from the Dash 8 series. On the 4-axle side, there was the B32-8. This is one of the first production models of the Dash 8 series, utilizing a 12-cylinder variant of the company's 7FDL prime mover referred to as the FDL-12, again making 3,200 horsepower. Production lasted from 1984 to 1989, with just 49 units produced. Another variant of the 4-axle Dash 8 locomotive worthy of mention is the B39-8. Very similar to the B40-8 being produced earlier, the main difference between this model, which incidentally sold again 145 units, was that it rode on an earlier variation of the high-adhesion 4-axle truck that had previously been used on GE's own Dash 7 models and could trace its heritage back to some late-production Century models from Alco. These locomotives were again propelled by a 16 variation of the 7FDL prime mover, known again as the 7FDL-16, rated at 3,900 horsepower. Another 4-axle model of GE's Dash 8 series of locomotives that needs no introduction, especially to Amtrak fans, is the Dash 8 32BWH. This locomotive was again propelled by the FDL-7 12-cylinder variant, making 3,200 horsepower. In addition to being geared for higher speeds for passenger service at over 100 miles per hour, as opposed to roughly 65 for a freight locomotive, it was also equipped with an alternator that robbed some power from the prime mover, which in turn it used to generate HEP power for the passenger coaches it pulled, but also prevented the prime mover from having to spin at high RPMs much like the F40, and also removed the necessity for a separately powered HEP power generator to supply power to the coaches. Designed to help supplement the aging F40 fleet in a time in which the new Genesis locomotives hadn't quite finished development and production, but at the same time Amtrak found itself short of power, these 20 units were built specifically to fill this gap, between 1990 and 1991. Another notable model variation in the 4-axle series of GE's Dash 8 locomotives was the Dash 840BW, produced in 2 separate orders for Santa Fe, starting in 1988 and ending in 1992. Being 4,000 horsepower, these locomotives were propelled by the 16-cylinder variant of the 7FDL-16 prime mover, which again had been refined from the earlier Dash 7 series, rated at 4,000 horsepower. 2 noticeable distinctions make this locomotive very notable. To start with, as signified by the W, this locomotive has a wide cab, and was one of the few 4-axle locomotives built factory new by GE that would have this particular cab. Also of note of these 84 locomotives produced is that they were the last Type 4-axle locomotives produced by GE factory new, when production ceased of the final order in 1992. Then, there was the Dash 840B. These particular locomotives and the later Dash 840BWs would be the most powerful 4-axle locomotives ever produced in North America, factory new. 151 of these standard cab units were produced for several different railroads in the United States between 1988 and 1989. They were powered by GE's 7FDL-16, again a further refinement of the replacement prime mover that was found on the original U-boats, which was simply known as the FDL-16, again rated at 4,000 horsepower. and utilizing 16 cylinders. Now let's look at some of the 6-axle variations of this model. There was the C32-8, similar to the B32-8, only in this case equipped with 6 axles, and again propelled by the 12-cylinder variant of the FDL-16 prime mover, making 3,200 horsepower. Just 10 of these locomotives were produced in 1984. Another notable 6-axle variant was one of the more successful ones, and that is the C39-8, with 161 locomotives produced between 1984 and 1987. Again, this locomotive utilized the 16-cylinder variant of the 7 FDL-16 prime mover, producing 3,900 horsepower. Another variation of the 6-axle models of the -8 series of locomotives is the C40-8, which also had a later variation simply referred to as the CW-8, again indicating that this version had a wide cab. This particular locomotive featured a tweaked version of the 7 FDL-16, producing an even 4,000 horsepower. Another notable but quite rare variant of the -8 6-axle series was the Canadian-only C40-8M. Again propelled by the company's 7 FDL-16 prime mover rated at 4,000 horsepower, these locomotives featured a unique cowl-style body that covered the whole length of the engine room and frame of the locomotive, allowing for easy cold weather access under very harsh winter conditions, as these locomotives were special ordered by CN. Roughly 85 of these units were produced for various different Canadian railroads, most of which have been scrapped. Then there was the -840CW. This locomotive is very similar to the -840BW, featuring the same 16-cylinder 7 FDL-16 prime mover rated at 4,000 horsepower, and of course the wide cab. 756 of these particular locomotives were produced between 1989 and 1994. And last but certainly not least, there was the -844CW. In addition to riding a new variant of the 6-axle trucks produced by GE, these locomotives were equipped with a specially upgraded variant of the 7 FDL-16 prime mover, in this case rated all the way up at 4,400 horsepower, the most powerful single locomotive to be produced in the -8 series. While they were technically part of the -8 series, these were actually considered to be pre-production -9s, as they featured many of the new enhancements from the -9 series, including the new trucks, as well as the updated FDL-17 prime mover that was before mentioned, making 4,400 horsepower. Just 52 of these locomotives were produced for CSX in 1996. While the -8 line of diesel locomotives for GE were highly successful, it's hard to pin down an exact total for all locomotives in this particular series produced. The number is somewhere south or north of 3,000 total produced. All this said, however, AMD's total production of its GP and SD series of locomotives from this period with the 50 series and even its 60 series still failed to match GE's new -8 line of locomotives for sales. Now, I'm sure many of you GE fans at this point in the background are raising the roof as we used to do back in the early 2000s. Well, don't get too excited, because while GE did dominate sales of new locomotives, they made a critical error in the used locomotive market. This neatly segues us into where they are now. The majority of these locomotives were essentially scrapped as they came out of service somewhere in the mid to late 2010s. This might seem quite shocking at first here as to why an engine that was known to be this successful and this efficient would fail to find second lives, especially considering the huge uptick in regional as well as short-line railroads in the United States. Ironically enough, a lot of this has to do with GM's previous success, as well as the nature of their previously designed two-cycle combustion prime movers. You see, the -8 models, while much more efficient and much better in emissions, and much better overall in terms of a locomotive, suffered from the fact that they were much more high-tech. They had 4-cycle combustion prime movers, they had many electronics, including microprocessors, as well as electric subsystems that operated within the locomotive to manage them. In sharp contrast, the earlier GM products were simple 2-cycle combustion prime movers with noticeably more simplistic electronics, while noticeably less fuel efficient, as well as failing to meet new emission standards that were coming out at the time, such as the Tier 3 and Tier 4 emission standards, which would essentially temporarily force EMD, eventually to be known as EMC Corporation, as it would later be acquired by Progress Rail, a division of Caterpillar Incorporated, out of domestic locomotive production for a time, still gave the company a huge advantage in terms of used locomotive sales as well as parts and supports for these locomotives. GM had also long since established factory rebuild programs for its locomotives, such as the GP20 Eco as seen above, which takes a standard GP9 and completely overhauls the engine, most notably its prime mover, with the 567 being replaced with a 710 8-cylinder turbo power plant, now making it even 2,000 horsepower, as opposed to the GP9 1,750 horsepower. And while these models didn't necessarily make all the new environmental standards, they did retain the simplicity that kept these locomotives so popular for so many years. And on top of that, these particular models would come with factory warranties. Then there was the fact that there was such a massive install base / parts availability for these old style locomotives around. The two-cycle combustion prime movers were largely intercompatible, which made upgrading them very simple and easy, which also meant that there were several parts available due to engines that had been scrapped or weren't worthy of being rebuilt, meaning rebuilding one of these locomotives if a company already owned it wasn't as expensive or as daunting as a task, especially considering the simplicity of their mechanics and electronics. But what has to be the most notable factor in this entire situation is the fact that there were so many mechanics that were familiar with the two-cycle combustion prime movers. It was very easy to find people who were skilled in repairing these engines. In sharp contrast, GE at this point did not have any factory rebuild or support programs available for its older models, nor did it have factory rebuild programs, etc. Essentially, a railroad buying one of these locomotives was subject to paying hundreds of thousands of dollars in overhaul costs, and so while they may have been cheaper on the used market, it was still a daunting task to get used to something this high-tech compared to the simplicity of the two-cycle combustion EMD prime movers and locomotives that were so prominent, and that short lines and regionals tended to prefer, let alone finding mechanics and documentation and parts, etc. to keep these modern machines working effectively as well as reliably. Speaking of reliability, the Dash 8s as they aged did develop noticeable issues. The most noticeable of all of these issues were the infamous turbocharger fires, caused by worn-out internal components such as gaskets and valve guides, which would slowly but surely allow oil to seep into the exhaust manifold, which is also where the turbocharger got its return gases, allowing it to spool up. This highly flammable mix was subject to easily going up in flames, from something as minimal as a stray spark coming from a somewhat worn, if not heavily worn, prime mover. These issues essentially doomed a lot of these locomotives to the scrap torch and essentially kept GE out of the second-hand market for locomotives factory rebuilt, as it simply didn't have a mechanism at that time to rebuild these locomotives and to offer them with factory warranties. GE would eventually solve this by actually developing its own in-house rebuild program for these locomotives, buying a lot of used examples up on the market, refurbishing them, and then selling them to customers with factory warranties, essentially doing what GM had done. Unfortunately, it'd be too late to save many of these locomotives from the cutting torch. Today there are far fewer Dash 8s around, and they're becoming a very rare locomotive, ironically enough, despite how many were produced. The Dash 8 series of locomotives was definitely the pivot point at which GE dominated the American/North American locomotive market. This would essentially force EMC, formerly EMD, to trade places with GE, with EMC now playing second fiddle to GE, which to this day no longer dominates North American locomotive production, at least of new locomotives. And that's going to do it for this video. If you liked it, give it a thumbs up. If not, thumbs down. Please like and subscribe, and as always, keep the metal side down.